Today we're going to be analyzing three different basketball players. So we have Wilt Chamberlain, Michael Jordan, and LeBron James, and we're going to be asking who was the greatest of all time? Who was the GOAT of these three guys? So a few topics we're going to go over is we're going to go over percentiles, cumulative relative frequency, which we just talked about today in class, and then standardized scores, or something that's known as a Z-score, which you may or may not remember from a few years ago. So the very first question that we're going to ask is who did better on their SAT? So we have Mr. Youngsaver, who's a statistician and math teacher, versus Guy Fieri, which is the chef. He's also the mayor of Flavortown. Now, Mr. Youngsaver got a 1050 out of 1600 on the SAT, but they don't offer the SAT in Flavortown, so he took the ACT and got a 23 out of 36. So who should Flavortown College select? Should they select an SAT of 1050 or an ACT of 23? Now, these are kind of like, both of these you're like, well, I don't know. So what we need to do is we need to compare. First off, if I look at percentages, I'm like, okay, 1050 out of 1600 is a 66%. And then an ACT at 23 out of 36 is a 64%. But let's get even better because it's not that simple. There's different scores, there's different scoring systems, so I can't just look at the raw percentage. I want to see where did they fall within the distribution or how can they be compared. So a percentile is the percent of data below a certain data value. I would write this down in your notes. So if I ask you the question, we'll come back to the ACT, SAT scores in a second. If I ask you the question, at what percentile is the person who makes a salary of $43,000? Here it is right here. So it's that same salaries that we've been dealing with for a little while now. We see that if I count up all of these values, there's 12 values in total, and there are 9 values below. So the salary of $43,000 is at the 75th percentile of salaries. It is above 75% of salaries. So the percentile, what percent are below that number 43? 75% are below. So that 43,000 is the 75th percentile. Notice this is not to scale, but we can get our percentiles from this guy here. So thinking about your quartiles, remember that Q1 is at the 25th percentile, so 25% of data are in Q1. The median, Q2, is at the 50th percentile. 50% of data are below the median. Q3 is at the 75th percentile, so 75% of data are going to be below Q3. And then you have that top guy right there. So who should we select? Let's first look at what percent of people did each taker outscore. So where do they lie? Because each of these tests have different elements. Each of these tests have different things going on here. So here are a few charts, and these are going to be cumulative frequency charts, right? So cumulative, it's going to accumulate all the way up to 100%. When I look at these highlighted scores, I notice that a 1050 is the 45th percentile, right? It's above 45% of people. And then a 23 is in the 69th percentile, or it's above 69% of people. So who should Flavortown College accept? Obviously, Flavortown College is going to accept the mayor of Flavortown, Guy Fieri, because he is in the 69th percentile, or the higher percentile than that SAT score. So it's more impressive. When we talk about cumulative frequency, if you were to take all that data and put it on a chart, so we take all that data from before, and we said, let's actually put this in a chart for the ACT scores. I noticed that an ACT score of 10 is in like the 0 percentile, right? But you can follow this up and notice, is an ACT score of 18 a good score? Well, if I go to 18, and then I go over to my y-axis to look at the percentile, I can see that an ACT score of 18 is in the 40th percentile, so it did better than 40% of people. It's okay, right? Like, this is not great. It's not going to get us to Harvard, but it's okay. If you're applying for an elite college and you want to score in the top quartile, we're thinking top quartile. All right, that's 75%. So let's go over and then drop us down to the x-axis to see what score that is. That score is a 24. So you would need to have a score of 24 or higher to be in the top 25%. The next thing that we're going to talk about are z-scores. Z-scores tell you how many standard deviations is a data point above or below the mean. So what a z-score does is it takes the data point, that xi, and then it subtracts the mean, there's mu, and then we divide by standard deviation, or that's sigma. So let's actually look at who had the best score. Now, when I look at this, I notice that this is 30 points per game, 30.1, 30.1, and 27.1. So if I were to look at all these guys, I would say, okay, well, Wilt and Jordan were the best because they had the most points per game, and then LeBron was like third place, right? He didn't have as many as the other two. But it's super important to note that there are different things that happen in different times. Wilt Chamberlain played in the 60s. There's different rules. There were different scores, like different things happened in the NBA in the 60s than in the 90s and then in the 2000s or 2010s. So let's actually ask a better question. Not who was best, but who was best relative to their time. During Wilt Chamberlain's period, the NBA's average was 10.8 points per game. During the 90s, the average player in the NBA had 8.7 points per game, and then in the 2010s, the average NBA player had 8.4 points per game. So I can probably look at this now and I can like clearly see, okay, I feel like one of these may be higher. I'm not sure. Jordan looks higher, but let's actually get some data here. So when I subtract the mean from each of those data points, I get a difference of 19.3, 21.4, and 18.7, respectively. So with this information, I can say, okay, Jordan's clearly number one because he did 21.4 points better than Wilt Chamberlain, than LeBron. But let's also talk about variability. Here are two different data sets right here, two different data sets of a normal distribution, and one of them has higher variability than the other. Variability is like how much does the data vary, or the standard deviation. If you guys remember back in Algebra 2, we talked about standard deviations on the normal distribution curve, and we talked about 68%, right, are within one standard deviation, 95% are within two, and then 99.7% are within 3 standard deviations. So those tails don't have much data in them at all. Our first data set has a low variability because it's pretty tall. Everything is very close to the mean. It's saying that my standard deviation is 2 points per game. So this grouping of data is all very close. Whereas we can also look at a graph that has a high variability. That means it's going to be more flattened or more smushed out. Our values are going to vary greater from the mean here. So this standard deviation is 4. So from that mean value of 10, one standard deviation is going to go 4 below or 4 above. 2 standard deviations is going to go 8 to cover the same amount of the graph that normally we just went for 2 for this above one with low variability. So let's go back to Mr. Youngsaver. Here's him playing basketball. Pew, pew, pew. And let's say that he averages 14 points per game. If we're comparing his data set with the low variability, it is 4 above both of these means, but with that low variability, we are 2 standard deviations above the mean, which means that there's barely anyone that's doing better than him. But with that high variability, so if he's playing against or we're comparing against a team where the people are varying pretty greatly from the mean, that is not as impressive because I can see that there's still a big group of people. All this data here, if I were to shade it in, is going to be above the mean. So, I mean, it's still very good, right? Like we're still in a top percentile, but not nearly as tippity top as that low variability data set. When I actually look at the percent above the mean, it's 2.5% versus 16%. So the idea about this whole standardizing, or like the standardization, is that a point's location in the distribution depends on both the distance from center and the distribution spread or variation. So let's go back here. Having a z-score right here of +2, a z-score of +2 is going to be more impressive than a z-score of 1, even though the score is the same. So we have to look at two separate things here. We shouldn't just look at the location and the distribution. We should also look at what is happening, or like how much is the distribution spread. So let's go back and let's actually standardize these point differences. So going back to our data set, we know Wilt Chamberlain averaged 19.3 points per game more than the average player. Jordan was 21.4 points per game more, and then LeBron was 18.7 points per game greater. But let's look at like how much did those point values deviate, or how much was like the spread or difference between the average player. In the 60s, our deviation was 7 points per game, and then it goes down from there. So more people are scoring more consistently. So now let's say, okay, now that we know there's going to be more variability in the 60s and less variability in the 90s and 2010s, let's see what that does, or let's see how many standard deviations are away from the mean. Let's calculate that z-score. So if I take my number of points, I subtract the mean, so 30.1 minus 10.8, but then I say, okay, but the normal person did 7. I notice that we are 2.8 standard deviations above the mean. So he's still a top scorer, but we're not completely like in the super elite. I mean, we're elite, but this is not like top. Jordan scored when there was only 5.9 point variability. He was 3.6 standard deviations above the mean. Very good. And then LeBron was 3.4 standard deviations above the mean when we take into account the variability of 5.5 points per game, or the standard deviation of 5.5 points per game. So now, when I look at who was the greatest of all time, Jordan is clearly number 1. And then LeBron is a close second, and Wilt Chamberlain is third, because Michael Jordan's points per game was 3.8 standard deviations above the mean, making him the most unusually high scorer of the 3 of these great basketball legends. So let's look at, what about a not so great player? This is Adam Morrison, when he spent most of his time with the Lakers on the bench. In the 2009 season, he played 44 minutes total. So for comparison, 2,999 minutes, 2,960 minutes. We have a lot of difference there. 44 minutes total is not great. So let's ask, he's very angry about not being great. What's happening here? So while with the Lakers, he averaged 2.2 points per game. So the league average was 8.4, and then the standard deviation, or the variation or variability, was 5.5. So I'm going to give you guys a second. Please pause, and I want you to calculate Adam Morrison's z-score. I get negative 1.1 when I do my calculation. That means his score rate was 1.1 standard deviation below the league average in his era. So let's do compare. What does this mean? Positive, negative z-scores. We have a negative 1.1, and then we have a positive 3.4. If our data is greater than the mean, it is positive. If your data is below the mean, it is negative. That is all that means. So a positive z-score means the number of standard deviations to the right or above, while a negative is below. Womp womp. But it is all about the bling. Because even though Adam Morrison scored very far below, he had some guys that were really helping him out here, and he has more championship rings than Allen Iverson, Russell Westbrook, Steve Nash, Harden, Ewing, and Chris Paul. So even though he's 1.1 standard deviations below, well, he's getting helped out by his teammates. So then we ask, since he has more than everyone, is he actually really the GOAT? So what I want for you guys to think about, and we're going to discuss, I'm going to go back to these ACT scores. I know that this is all something that you guys are really into right now, applying for colleges. When I look at this percentile, I want for you guys to think, why isn't the maximum ACT score, a 36, in the 100th percentile? Think about it. Why are 100% of values not below? And then can you ever be above yourself? Think about these things, and we will talk about this on Monday. Friday. My goodness. Talk about it on Friday.